Hey everyone, this video is about rocket support infrastructure, also known as all the stuff you need to keep your rocket program operational. This is my particular implementation of these systems. Obviously yours is not going to look just like this or potentially could look, completely different. You might have things scattered out all over the place instead of being in one big box. But this is, as I said, my particular implementation and why I made the decisions that I did and everything that I have included in it. So real quick, here are the overlays for more or less everything. We've got the water to the rockets down here, supercoolant loops with the liquid hydrogen and oxygen, bunch of extra pipes which aren't hooked up to anything right now but are mainly usually hooked up to rocket unloaders and stuff like that. The gas system, power, automation, which is the most complicated part and the part we're going to be spending the most time talking about, but we'll cover that toward the end of the videos. That's a pretty big one. And lastly, conveyance, which is relatively simple. These two just are usually hooked up for the cargo rocket unloading and go down to main storage. Because I'm playing on Blasted series right now and the metal volcanoes are on the main planet, I don't actually have a need for the cargo rocket, so I don't have one in this particular run. I just pick up things with a regular rocket. Alright, so real quick, why I designed this the way I did. The total height of this entire block is 39 tiles, including the top and bottom, which, as you may have noticed, perfectly fits a max height rocket along with its rocket platform while letting you build straight across the top and straight across the bottom to create your nice rocket bays. For meteor defense, we currently have some bunker doors and some robo-miners just up to the top. This works neatly on the rad bolt engine side because they fit in between the rockets. It doesn't work quite so neatly with the hydrogen, but the hydrogen exhaust generally can melt the ice on Blasted series pretty quickly, so that system isn't exactly perfect, but a lot of things on here are a little bit of a work in progress. I consider this design largely finished, but as it is with all things in ONI, the more you play, you tend to iterate on things a little bit and they improve over time. Alright, so starting with the smaller sections and saving the biggest ones for last. First off, we have our labs at the top. It's split into two different sections, each with two lab buildings. We have our supercomputer, telescope, planetary, mission control, the regular lab, and the MST, all grouped together quite nicely. Lab bonuses and lights and everything. The way I've loosely set this all up is I have it so oxidized rockets and then eventually liquid hydrogen and oxygen will be on the right and radiation will be on the left. The decision behind grouping those as I did was simply because the MST has its input on the left, and it's much easier to have the rad bolts come from the left because the dupe's axis on the right than have them come from the right, and you have to do a little more finagling to avoid them hitting the dupes, and that's pretty much the entire reason behind that. But in the early game, I will put my petroleum rockets on the right, my CO2 rockets on the left, etc. Generally, anything that needs an oxidizer, I stick on the right. We've got an oxylite refinery here if needed, although I don't really use it very much anymore because my go-to plan in games tends to be more or less CO2 rocket until I get the data banks I need. Then I go straight into rad rockets and then liquid hydrogen, although I usually tend to only have one or two liquid hydrogen rockets per game. I've been trying to stick a little bit more to rad rockets because it makes things easier when landing on planets, because rad rockets generate relatively little heat, so they don't just incinerate the surface of whatever they land on, which forces you to build a rocket trench in on every single planet, as opposed to only your main. And on some planets, such as the superconductive, you frequently don't have a full 35 tile height between the bottom or where the magma is. Even on, the parts where there's more space, like this is only 32 tiles height. So it just makes your life easier when you can handle everything with a much smaller rocket. We've got the molecular forge over here. We got bins which hold all the special materials. I've got sulfur, graphite, niobium, and I think this was supposed to be thermium. But we have all the materials right there. I would have liked to get these more up here, but there just wasn't room. Oh, and another word on the size of this thing. The reason I chose the width of this as it was because I use... If you've watched my rocket interior video, which I will link in the description, and ideally you should watch before watching this one, I prefer to use the external O2 tank method, which amusingly enough is only on this rocket right now because these ones right here, due to restrictions on rocket height, have internal O2 tanks because they only do short trips. We'll ignore the water that's sitting on the bottom of that rocket right now. And this method of having an external O2 tank is sped up significantly if you have multiple loaders. It takes 18 cycles to load a full 5 height tank and 6 cycles to load a 3 height tank. If you have 3 loaders that can all be, loaded in from a different set of tanks, then you create an enormous buffer that allows, the loading of something like this in under 2 cycles. So that is, I consider to be kind of a mandatory part of designing a rocket support system that has chosen to use the external tanks over the oxylite method for everything. We've got, as I said, the oxylite refinery here. This is just a little supercoolant storage that I've set up. These just, keep it all nice and tidy. This section, I've got a little extra space. Didn't quite have anything to fill in there. The rest of it's filled out quite nicely. This side didn't quite fill out as nicely as the rest, but hey, it's pretty close to perfect. These are just extra hydrogen tanks, but they're kind of superficial because the main hydrogen storage is down here. And, transit tube takes people inside. I do keep O2 in here, but this is not for breathing. This is for thermal conductivity reasons because it's a lot easier to temperature control an area when you have air in it. But in reality, they're up here all the time with suits. If anything, this area has gotten a little too cold this run. I've done almost too good of a job of keeping my base chilled. This is absolute temperature, and this is relative right now. But yeah, as you can see on absolute, everything is super cool. And it's actually going to cause a little bit of an issue because even with ceramic pipes, I've started to freeze the water in the lines. That's a minor issue I'm working on, but yeah, I'll probably wind up further insulating the column by putting more igneous over the pipe because that helps, prevent it from exchanging heat or cold with the surrounding tiles and environment as they come to the surface. So for the hydrogen and liquid oxygen system, I do use 2 tanks that are roughly the same size. This is just something I just set up, kind of off aesthetics. This isn't exactly ideal because hydrogen is stored 1000 kg per tile and oxygen is half as much. However, in liquid hydrogen oxygen rockets, they actually use 4 times as much hydrogen as they do oxygen. So if you're trying to keep an even balance, ideally your hydrogen tank should be twice the size of your oxygen. But it doesn't really matter because in the end, this is more than you will ever need. Even if you were running an entire fleet, this has no problems cooling it fast enough. Now, obviously, we have supercoolant in the loop. This is being run at minus 250 something-ish. The thermometer is set to minus 253. I have fiddled with this number a lot, just moving it up and down, trying to find the right value so it freezes things or liquefies things well enough without actually freezing it in a solid hydrogen, which I have definitely done accidentally a few times, and when I was overshot slightly. This loop is required if you don't have insulite, because if you don't have insulite, then even with ceramic, the trace heat from the hydrogen rocket will eventually boil the hydrogen and liquid oxygen in the pipes, causing them to break. So you can get rid of this without insulite. Once you have insulite, but honestly, I consider insulite to be a bit of a meme. It is the most annoying space substance out of the 3 to gather, and it is arguably the least useful because good design combined with ceramic is enough for literally every design in the game. So yeah, you need a lot of insulite to actually make the pipes too, because obviously it's 400 per tile. So yeah, just replacing these alone, like with insulite, like forget about doing other things with insulite, but just replacing these pipes is going to require, with just a straight line, is going to require more insulite than you think it will. And I did that last run when I replaced it with insulite, but this run I didn't bother, and I'm not going to bother. In fact, in this run I may not even bother with the tree at all. I may do it just for the sake of doing it, but I have supercoolant and thermium niobium already, and those are the more important and more useful materials anyway. So yeah, these loop back in. We have these set up with circuits set to hydrosensors, as well as the landed rocket platform, so that the pumps only operate when there's enough liquid in here and the rockets on the platform. Just saves a little bit of energy. The pumps will continuously run if there's a rocket sitting on the platform fully fueled. It's a little unfortunate, but there's no way to do a sensor on the rocket that turns off the pumps when it's fueled. It's, well, these are the only options you have. Fully fueled is not an option. That's only an option on the Radbolt engines, but not on the hydrogen engine. So, yeah, can't do that, unfortunately, but this is better than nothing. The upper sensor is there to just make sure the liquid hydrogen and oxygen doesn't actually reach the vent, because if it does, it can cause the liquid in the pipes to condense, or the gases in the pipes to condense, and that will cause the pipes to break. So that's all that those do. Same thing with the temp shift plates. You can see in the back here, they're all made of aluminum, obviously, so are the pipes, only the best for this stuff. Everything here is made without space materials, aside from the supercoolant. That part is inescapable, and I consider the water planet to be the single most important planet to colonize or harvest once you have your space program going, because supercoolant is by far the most useful liquid. If you put these temp shift plates up top, I used to have them in a 1, 2, 3, 4 configuration, then that will cause, again, the gas in the pipes to condense and liquefy, which will break your pipes. So just 3 along the bottom, and make sure they're not at the outer edges. You don't want to have, because remember, temp shift plate operates in a 3x3 area. You never want to have that 3x3 area overlapping on insulated tiles or anything like that. So this is good. It can be a little, not slow per se, but it might look like it's not quite starting up properly when you get it started, because the first little bit on the bottom has to liquefy before the temp shift plates can actually start cooling down and working. But once the system gets going, it's perfectly stable, perfectly fine, and it will self-start with without any micro required. So I'm generally very happy with this design. One last thing, a little trick that I realized that turned out to be kind of an off-the-cuff idea that worked out really well, was running the insulated running the hydrogen gas through the liquid oxygen, and then obviously getting the liquid oxygen first before you insert the hydrogen, because if you insert the hydrogen straight up and it's coming in at like 20 degrees or something, or just anything that's not a super cold temperature, it can cause flaking and other undesired effects here, just make things take a lot longer to stabilize. Hydrogen has a very, very, very narrow margin in which it's liquid, compared to oxygen, which has something like a 20-degree margin, which is plenty. So with the hydrogen, running it through the liquid oxygen cools it sufficiently that there are no issues once it liquefies. The supercoolant only runs through the hydrogen area, and the tile is part of the cold injector. The cold injector is pretty straightforward, just 2 doors attached to a thermosensor. This is set to -212. That number seems to have worked great for me. And that should more or less cover it for the liquid hydrogen and oxygen side. Now, this is actually supposed to be connected. I just have it disconnected right now because I'm not using Oxylite right now, because the way I have this wired is it'll make Oxylite until the bin is full, but I'm just literally not making Oxylite at all this game, so yeah, I just disconnected that entirely, and normally this is supposed to be a pit of liquid the same way this is, so that your Oxylite doesn't off-gas. Okay, I think that covers it for the less complicated systems. We've got a little door up top so they can get up top. This space scanner I just stuck up top and seems to be working more or less fine. with the meteors. I think I need to adjust this timer value. I have it set to 45. I think I may actually need to swap these two and change to a buffer gate to get it to work entirely how I want to, but you know, you generally get the idea regarding meteor defense. These doors are shut, it drills everything out, the door is open, everything falls, you know, nice and neat. One idea I did have was that I could, you know, once the telescope is done scanning everything, the way it's done scanning everything right now, I could actually remove the telescope and put the space scanner up here on like an elevated platform or so, and I might do that at some point because that works. I'd have to move these slightly to the side, but I'm pretty sure I could find a way to make it fit. But there's no, you know, real problem with it being on top. A word about the top of the map. I was a little unsure about how much space I needed with the top of the map, but it's pretty clear now after setting all this up. Around 4 tiles, I would say, is the absolute minimum because that's how big the scanner is. Any more than that, and you won't be able to put a scanner on top. It's something you want to put on top, and your robominers are also going to get a little boxed in. When meteors land, they tend to put usually at most 2 tiles with each landing. I'm not sure if they can put more than 2. I can't remember the last time I've seen them put more than 2, and have yet to have one of these get entombed because it put down 3 tiles or something. So these also need to have 2 tiles between that and 2 tiles in that. So if you're doing it like this, as opposed to, you know, doing it like from the side like that, then yeah, you definitely want to have around 5 tiles. But yeah, you could get away with 4 if you tighten things up a little bit, but I wouldn't go lower than that, and I would do 5 tiles if you can. We have lead here just for a little bit of extra radiation shielding because this run is on maximum difficulty. So I've tried to insulate that a bit more. I'll probably wind up moving this slightly to an area where people are less, you know, instead of it being directly over the lab. Or as I said, I might be moving it down inside and then extend the radiation shielding. But as you can see, that makes a fairly solid difference. Another word about where you place this at the top of the map relative to the top. You want to have the bottom area of this specifically around 7 tiles under. I went a little further. It's 7 tiles under the rocket pad. I went 8, but you really only need 7 tiles. This area down here, you want to have space exposure unless you're doing something regarding capturing rocket exhaust, which I usually don't bother with anymore. The reason behind that is you want the exhaust to pretty much dissipate immediately. You don't want it to stick around and heat things. You want it to just be gone immediately, no questions asked. And having it behind the vacuum area lets you do that. If you do need to capture it, you can always fill it in with back wall, you know, obsidian tiles, which would prevent the gas from escaping. But it's important to note that this natural background that you see that goes up and down, this essentially functions as a back wall tile in terms of gases escaping. As you can see, it's space exposure here and not space exposure here. So if you place this too low, you're going to have a much more difficult time with controlling your temperatures up here, and a lot more difficult time controlling your rocket exhaust. Okay, now for the fun part. All right, this is the radiation rocket side, and is really the heart of this entire operation because, as I said, I'm kind of a rad rocket junkie these days, and it's a lot more complicated than doing petroleum or hydrogen or any other rocket, all of which are relatively simple by comparison. My setup is a little more complicated than most because it has the MST and the launcher and, you know, everything all in one site. I wanted to have everything that used rad bolts in one area, and to take that and just have it all fed by one thing. Now, there are 2 options as to what that thing could be. The first one is Weezwarts. Those obviously aren't present right now because that's not what I'm using this game, but this is essentially the pocket where the Weezwarts would go. 3 here in each of these areas. and these generators would turn on. As you can see, I have it disconnected right now from there because I'm not doing these words this game. Instead, we have another wire that runs all the way down to the nuclear reactor, which is something I'm not going to talk about much this video for length reasons, but I probably will do another short video on it. But long story short, this fires rad bolts up through here. You can shoot diagonally through this corner, and it goes straight up through this tube, up through here. It does cross the dupe path, but I haven't really had any issues whatsoever with dupes running into rad bolts. You know, if they run into one occasionally, it happens infrequently enough that I have, you know, in 1,300 cycles, I've never really even noticed it or had an issue. These shoot rad bolts up here, which then get stored in this area. And then all these reflectors do, combined with all these circuits, is send the rad bolts where they need to go depending on what is requesting rad bolts. So I can show you real quick how it works when a rocket lands. These are all full right now, so this is going to come down. It's going to be missing some rad bolts. And a few things, a few really, really important things regarding rad bolt requesting for both the rockets and the MST and the launcher. This is being controlled by, you know, the send a green signal when a rocket is on the platform, obviously combined with send a green signal when the rocket needs fuel. You know, it sends a signal when it's full, so obviously it's gone through a NOT gate. This will send a signal that the rocket is on the platform long before the rocket lands, like a good 30 seconds, and that's what this particular filter gate is for, is to delay the signal by 30 seconds so it doesn't start sending out rad bolts too soon. And so it'll wait 30 seconds, which is really more 10 seconds because we're on 3x speed. And as you can see, the rad bolts go across, out, and into the rockets, and once they are full, the circuits turn off again. We're now showing red signals, and the signal going down to the nuclear reactor requesting rad bolts is now green because we are now missing a few rad bolts. Same thing here with the filter gates. These are also, I believe, 30 seconds. It's the same issue here with these two filter gates. Whereas if these are missing rad bolts, like if someone comes here and uses one of these things or uses this, or this launches something and is then requesting rad bolts, what will happen is these will start requesting rad bolts when they're just missing like even one rad bolt. And then these will go fire like, you know, some giant rad bolts and, you know, waste huge amounts of rad bolts because it only needed 10 or something like that. So with these, you definitely also want those, you know, filter gates after your NOT gates in order to prevent that from happening. Okay, so onto the details of the automation of how I had this set up. The ribbon is huge for just making things a lot simpler. I originally had this without a ribbon, and then as I was iterating on the design, it was getting worse and worse and more complicated. I sort of rank my circuit design's elegance by how many bridges I have to use or how many I can avoid, and I managed to get all this done with only using one bridge, fortunately, which is not bad considering the complexity of the design. And the automation ribbon just helps hugely with keeping those organized. Again, this is one of those things that looks far more intimidating than it actually is. There are 4 signals being carried on the ribbon. Those are number 1, the MST needing rad bolts. Number 2, the launcher needing rad bolts. Number 3, the rockets needing rad bolts. And the 4th signal is simply this timer right here. This timer is set to 120 and it just goes round and round and round. And what this does is it makes sure that this governs all of these, all of the rad bolt chambers, and makes it so they're only allowed to shoot with the green. And the reason you need to do this here is because if you don't have something like this, what'll happen is you'll send the green signal from your rocket saying, hey, we need rad bolts, and these will just start machine gunning rad bolts out constantly. And these will be full, and these will still be firing, and you will waste huge amounts of rad bolts before, you know, the latency in the system catches up. So by having a restrictor like this, you make sure that when the rad bolt sets are fired, there is enough time for the rad bolts to travel to the rockets and be stored before the next volley is fired. So that part is mandatory, and you absolutely need to have something like that in your design. Another really quick tip, and a very, very important tip. Rad bolts lose, the little rad bolt charges on them based on the distance that they travel. If I can, just perfect, right on time. So you can see right here, this is 196 rad bolts. It's firing from 2. And when it goes through here, they wind up condensing into one big bolt. But the amount of rad bolts these lose, I believe, is 1 rad bolt per tile, or not, like even less than that. It might be like 0.1 rad bolts per tile. It's a very, very small amount, but it's a fixed amount based on the tile. It's not percent based on the size, the chunky size of your rad bolts. So you want to, these are set to default 50. You want to have them set to default 100, and all your generators and all your rad bolt chambers, you want to have these set to 100, and that essentially doubles the efficiency of your rad bolts by having the amount of loss you'll have from travel. And as you can see, the amount of travel is relatively low, or the amount of loss for travel is relatively low, coming all the way up here, up to the storage area, if it'll let me actually mouse over the damn thing. 193 up here, despite traveling all the way up from the nuclear reactor. So we're talking about less than a 10% loss from when it's fired to when it winds up in the rockets. So yeah, I'm pretty happy with that. If you can keep your loss under 10%, I think that's a pretty good barometer for a good design. Okay, so other things I have in this design, and this now is getting on to a little more specific implementations about my particular design. As I said, the key things you need to worry about in any design is having, the filter gates after each one. You need to have some kind of timer restrictor to prevent your chambers from dumping all your rad bolts, etc. But going into the more specific implementation of what I have done here, we've also got this switch right here. This controls the launcher. This is more or less roughly set up to shoot food at the tree. I usually just wind up shooting pemmican or berry sludge or something that doesn't spoil at it to keep things a bit easier. But you could also do something with dehydrated food or whatnot. The thing is, the awkward thing with setting it up is if you're loading food in via here, there's no way to restrict this storage to anything less than 1,000 kg. So any food you're going to load in here is going to be 1,000 kg worth, and obviously that's not good if it's a spoiling food. Because even though it's relatively cold up here, well, up here it's not as cold as it is down here for a deep freeze, but as there's oxygen up here, it's not a deep freeze atmosphere, so any spoilable food will eventually spoil. So that's why I've just said fuck it and use just pemmican or berry sludge only. So there's that there. Let's see, what other circuits do we have here that are important? One little trick that I did here is I have this set up so that when the launcher or the MST requests rad bolts, it always requests from the first rad bolt chamber only, because that will be the first one to be filled. That one will always, if any of them have rad bolts, it'll be the first one that has rad bolts, because they come into that one first. And so when these two activate, they just send a signal to this one to activate. However, when the rockets activate, it'll demand rad bolts from every single one, including the first, which is why we have this OR gate here. So it will take and accept a green signal either from the ribbon signal 1 or 2 or the ribbon signal 3 for the rockets to send the rad bolts over. This AND gate, as you can see, this is the 4 out, so this is just the timer governing everything. That's why it hooks up to both sides. These two are the 1 and 2 requesting rad bolts, which is why they're just joined together, because they're just requesting from the same one. However, the circuits are still different because of the paths that they take. I'm going to go ahead and trace the rad bolt paths here real quick. As they come through the Weiswarts or come through the reactor, they come straight through here into these chambers, bounce through here, and then go into here. If every chamber is full, which I can show you in a minute here if I simply let it run and stop pausing so much, then the rad bolts just travel in a circle over and over and over in here until they dissipate. I could set up something where I take this and bridge it over here and run it up to this, and that would make it so that when this turns red, aka telling the reactor or the Weezewarts that, hey, we have enough rad bolts, stop, then this would just shoot out into oblivion. But right now, once it's all full, it just circles uselessly, which really makes no difference because reflecting rad bolts doesn't consume power or anything. A lot of these other NOT gates and whatnot, yeah, there we go. And yeah, so it just does that once they're all full. As I said, if you don't like that behavior, you can just take this wire here, which is the rad bolts or full wire, and hook it up to that, and that will just cause it to fly out into oblivion and be lost forever in space. I think that more or less covers it for the details of the automation here. I know it's a bit complicated, but hopefully you get the general idea. And as I said, the chances of you copying this verbatim, not saying you can't, but it's obviously going to be a little challenging just to copy. And you may want to simply take the core ideas and implement them in your own design. Okay, so a few more things about the rocket bays. Before I cover this, there's one thing I wanted to mention on the hydrogen bay that I forgot to mention when I was covering the hydrogen exhaust. As you know, hydrogen exhaust gets very hot. As you can see, some of these are still pretty warm from the previous exhaust. One little trick I did in order to make cooling the hydrogen area a little more reasonable, and to make sure these don't just keep getting endlessly overheated until something dumb happens, was I took the chimney for my base, which is this, which runs all the way down to here, which is set up to an automation circuit to turn on once the pressure gets too high down here and it detects no oxygen. It will pump waste gases out the chimney here and exhaust them here. And that waste gas exhaust has been more than enough to keep things, from getting a little too ridiculous. As you can see, some of them are a little too hot, but I don't care about these rocket port extensions getting too hot. What I care is if the heat starts getting over here, because that leads to the door to the main base, because that's where it could actually cause issues. Word on materials. You want to use tungsten for all your wires around the rockets, even under the rad bolts. You want to use tungsten as much as possible. It's pretty much my main use for tungsten, is just putting rocket wires under them. In late game, once I have enough tungsten, I just go ahead and just make all wires out of tungsten, because it's there's a lot of different metal types in the game, and that's tungsten's claim to fame, is it has a really high melting temperature, so I tend to just set it on wires and then just leave it on that once I have enough. But in the early game, when you don't have your tungsten, or early mid game I should say, or really late mid game, when you don't have your tungsten volcanoes set up and you only have your starting wolframite that you found in your ice biomes, you want to take that wolframite, turn it into tungsten, and save it for your rocket wires. Alright, now the last thing to discuss, and the most recent addition I have done to this system, and what you've probably been wondering about, are these signal counters. Okay, so real quick, I want to go over the rocket automation on the pads under the rad bolts. The output being hooked to the input is just so you can set up automated rocket launches by just selecting crew and not having to hit the button. I mean, it sucks that you have to select the crew every time, but I find it's I'm more used to that than hitting the button, so that's an optional thing to do. There are two sets of wires going here. There is the AND gate, which hooks up the rocket being on the pad and the rocket needing fuel. You need both of those, because obviously otherwise if some other rocket is on the pad and doesn't need fuel, then it could send a green signal when you don't want it. So you want to hook up rocket on the pad and then rocket needing fuel. Those go hook up together, come out the AND gate, and that goes to the filter gate and gets injected over here into circuit connection number 3, which asks for rad bolts for the rockets. The second, so the new connection, which I've just set up, It's just running another wire from that original setup, which goes to the rocket pad 1, and that goes to the reset switch on the signal counters, and then the increment 1 is set up to a timer, which is just set up to activate very briefly once every 10 cycles. So the purpose of these is to increase by 1 every 10 cycles, the rocket is gone. And this is the evolution of me trying to set up some kind of alarm or some kind of system where my rockets, for when my rockets ran out of O2. What I used to do was set up an O2 sensor on one of these pipes and then hook it up with a notifier that would give me a notification if it didn't detect O2 on one of these pipes for a certain amount of time. That had issues. It never really worked how well as I intended. Plus, if the rocket was far away and it ran out of O2, then they wouldn't have enough O2 to make it back home, because these pipes go pretty fast compared to how much is in the tank. So that system didn't really work as intended and has eventually been replaced by this system. And what this does is it just increments by 1 every 10 cycles the rocket is off the pad. Now, all my rockets roughly have the same lifespan-ish. They're either single-man rockets off the gas cargo, which has an O2 lifespan of about 60 cycles, or a 2-man rocket with people that are vacillator juiced. This is my only 2-man rocket right now, and both people in it have all 4 vacillator buffs, which means they only consume half the oxygen each, which gives it a nice 20 cycle duration. So by looking at these numbers, I can see how long a rocket's been off the pad, and if I see one of these numbers getting up to like 4 or 5, it means I need to, take a look at the rocket and consider bringing it home. Another idea I had for this that I hadn't implemented yet was hooking these up to a notifier somewhere where that, just bridge. I guess I'd have to bridge these all over. I was trying to figure out a way to do it. As I said, I try to avoid bridges and have elegant connections, but yeah, I could either just put a notifier next to each one or bridge them up top and have a single notifier located somewhere, so that if any one of them hits, 4 or 5 or any chosen number, it sends me a warning. But yeah, this system has worked pretty well, and overall, I'm pretty happy with it. So yeah, there you have it. There is my rocket supporting infrastructure. We'll give it one last look, and one last look at the overlays, and try to think if there's anything I missed, and I don't believe there is. Rockets where you have a non-standard O2 or water configuration ideally are located more closely to the command center, because if you have to do the weird pipes like this or the weird O2 pipes like this, the shorter you can make them, the better. I always try to conserve materials as much as I can. But yeah, this was for the beachhead rocket, which had this, but that was before I came up with a new beachhead rocket, which has lead dock, Atmos suit, internal tank, etc. I'm probably going to make a video on the updated rocket designs I did for maximum difficulty at some point as well. So you will get to see more about that then. So yeah, there's our liquids, there's our gases, there's our glorious circuits, power, and the trivial little bits of conveyance. There you have it. I hope you guys enjoyed this video. I stream most days, evenings Pacific, to late night at Twitch TV SF Hobbit. Thanks for watching.